And let's jam. All right, class, welcome to Monday. Woo. We just talked about the schedule. So if you want to go online, those that are not here in class, if you want to go online, we set up the schedule for the rest of the year. But right now we are in chapter 10. Chapter 10, it says topics in analytic geometry. And topics just means all the leftover stuff. It's not a single topic. So we're going to jam with this here. Before we get to the next, let's go with it here. So what are the leftovers of lines? That's 10.1. We're going to deal with lines and all the stuff we have not talked about. But it really is this. It's the fusion of lines with geometry, or lines and angles. Okay, so let's jam. So first things first, before we get started here, I'm going to talk to you guys about something called radian measurement. And we'll come. Right, we got radian measurement here. So we have degrees. Degrees can give us circles, or degrees of a circle, of an angle of a circle. And then another one is called radian measurement. And so let's figure this out. So definition, let's go with it. So if you take any circle whatsoever, how large, how small, doesn't matter. And what we do is we just take, I'm going to try to draw this here, like that. And then what we do is we measure out the radius. The radius is from here to here, and we'll call it R. We're good there. And here's a fun little thing. Let's take this radius. It's almost like a string of some sorts. We're good. We're going to take the radius and we're going to just put it right on the circle itself. So it's the radius going on the circle. And so let me put it in red. Let's do it blue. And so if I do that, so this little guy right here is going to be, I'm going to color it in blue, and it goes up to about like right here. That little radius folded on, that's one radius. We good there? Okay, good there. And I'm going to fold, let's put another radius on there as well. So this one is going to be the next radius. It's going to go here. It goes to about right here, and then it stops because we're just putting on the radius on the circle. That's one, that's two. And then we keep on going. And it gets all the way to here. It's like, oh man, why? Why doesn't math work out nicely? Look at that. It's like it almost measures to the halfway point and then it doesn't. That's not cool. Okay, and then we put another one on. Goes to about right here. Maybe a little bit further. Let's go. Okay, that's a radius, that's a radius, that's a radius. And again, doesn't matter what circle size it is, right? It's all going to be the same, because if you make this bigger circle, the radius will become bigger, and it's going to hit all at the same time. It's going to hit here, it's going to hit here, here. Okay, so we got 1, 2, 3, 4, 5. All right, one more comes across about right here. 1, 2, 3, 4, and this is 5. Maybe a little less, but that's about it. Yeah, 5. I'm stretching it out just a little far. I'm just going to hit it just a little bit further back right here. Okay, 5, and then we're going to go here. This is 6 all the way to here. And again, I thought it's going to hit, but it doesn't. So then I get this little extra portion here. And with this one, I can start measuring out, like, okay, how much measurement is there from here to here? So then I find out it's actually 0.28-ish. 0.28-ish of another radius. So 1, 2, 3, 4, 5. I don't know, guys, this is crazy. How many radii do we have? We got 6 radii. So if I were to stack any size circle, given any size radius, stack them up, they will always measure, always measure around 6.28. Yes, that is a number we know in mathematics, don't we?
Yes.
Whoa, hold on. That is crazy. Hold on. 2.6.2. If you divide this by 2, divided by 2. Yeah, this is 3.14. Hold on. So if this is 3.14, now let's get going here. So that means, hold on. If I convert this into like pi, right? Use the symbol instead of the numbers. So hold on. So any size circle, no matter what size, because the radius expands with the circle, it is always going to give you, from here to here, it's always going to give you pi radians to do half a circle. That is, okay, so then let's do this here. If that's pi, let's chop it in half. Maybe let's do this here. Let's maybe make it same as degrees here. So this would be, everybody agreed here, this is 180 degrees. True? Because halfway around a circle is 180 degrees. Full way around the circle is 316. Elijah? Oh, what is the point divided by 2? Is just to show you that pi is here. Instead of Joe, because he's smart, he needs a PhD. He realized right away that was 2 pi. But if you divide it by 2, you're like, oh, wow, that's 3.14. I know that number. Okay, if you divide it in half again, this is 90 degrees. You guys tell me here, 90 degrees is the same thing as what? Pi over 2, okay. Okay, then over here, let's go 0 degrees is the same thing as 0. Is that okay? Okay, oh, nice. Okay, hold on, you guys talk to me about this little bottom corner here. How many degrees? Yeah, how many degrees, first of all? How'd you even get that first? Well, it's 90 past 180 though, right? It's like another 90 away as we're adding to the 180. What would that be? 270, everybody agree with Luke, 270? 180, yeah, I think so, yeah, 180 plus 90 degrees or another corner. Gives you 270, and now the fun part begins. Give it to me in radian measurement. So if we did this, the way we got 270 was 180 degrees plus 90 degrees gave us 270. That means pi plus pi divided by 2 should give us, I don't know, need common denominators. Can I get a common denominator here and here? This will be 2 and 2. This will be 2 pi. This will still be pi, same thing. 3 pi over 2. Okay, so there it is, 3 pi divided by 2. And then let's wrap around all the way around. So 0, 90, 180, 270. So I'm going to put a comma here. Whoa, and it disappeared on me. Comma. 360 degrees would be, now we should just let Joe answer the question problem. Let's, Joe, go for it. Since you're the first one that came up with it. What is 360 degrees is equal to? Never mind, he does not deserve the PhD. Yeah, 2 pi.
That's what I said.
Okay, didn't hear you. Okay, so we go from 0 to 2 pi, so it takes 2 pi to go around the whole entire circle. And that is called a radian measurement right there. That is the definition of radian measurement and some measurements that we should know. Okay, how does this interact with lines whatsoever? We want to be able to figure out the incline of a line. And then we want to be able to figure out the angle between lines. There's something that we did not do from geometry. Remember when you had vertical lines come across? We never learned like, hey, what's the angle between those? We're always given it. Okay, so let's jam. Here it is. So first things first, if I have an X and Y grid, this is X, this is Y, and I have a line that's coming like this. straight across. What's the slope of that line? How steep is it going up? It's 0. It's not going anywhere. So in this case, I'm going to write theta for my angle, and theta is usually made for angles. Theta is going to be 0 in terms of radian measurement. Okay, let's jam the next one. So hold on, wait a minute. So you guys tell me here, what's going to be the angle of inclination to any vertical line anytime you fall off a cliff? What is this angle measurement right here? Ooh, in terms of radian measurement. Pi over 2. Theta equals to pi over 2. Okay, so now we got ourselves, oh, we can even label these guys now. Horizontal line. And this guy would be a vertical line. Awesome. That'd work. Okay. So then again, think in your head, this is 90 degrees, right? And so notice that every single time it is, well, this one right here, it's always in terms of the x axis. We always think of these guys as pulling off the x axis. Okay, two more. I'm going to have a line that goes like this. Now, it doesn't matter where it goes through, what it does, but as long as it crosses the x-axis somewhere like this. And I need my angle of inclination. I'm going to call it theta. But because it's less than 90 degrees, this guy is going to be called an acute angle. Oh, yeah. And guess what? If this guy's coming down this way, what does that look like? More than 90 degrees? Obtuse angle. Obtuse angle. So now the question, remember, it's just how it hits the x-axis. That's what we're looking for, right? How does it hit the x-axis? Oh, craziness. You guys ready? Back to algebra in your mind. Think about the slope of the acute angle line. Think about the slope of the obtuse angle line. What's the slope there? Oh, wait. I have like a lot of time to wait. Absolutely. If you go over here, this guy is positive slope because it's climbing up. So therefore it's going to hit the x-axis on its way up and always going to produce an acute angle here. This guy is going to be a negative slope. Okay, that's cool, guys. That's awesome. Boom, 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 boom. Now let's get into some fun stuff here. Oh, raise your hand if you brought your calculator today. Awesome, we'll need it here in just a bit here. So here it is, the definition first, and then we'll jump to our calculator here. So the inclination so it's the connection between the inclination and the slope. What is the connection? It's like this. So M, we know what M is. Everybody knows what M is. The slope of a line is equal to the tangent of the angle. Weird stuff. What? Okay, so tangent is a trig function. We didn't do chapters 3, 4, and 5, but we're just going to learn just this one only. We're good? Tangent of your angle. So we're not going to learn what tangent is. That's for trig. We're just going to learn how to use it in this context only. So if you want the slope of the line, or the slope where it makes with the x-axis, right? Not the slope of the line. So it's the tan, T-A-N. It's one of the trig functions here. Next year, we'll actually learn what sine, cosine, and tangent are. It's called tangent. Just in trigonometry, what we do, we abbreviate them to the first three letters, as opposed to writing it out. Tangent of, and then it takes too long. Okay, so let's jam with example number 1. Example 1. Find the inclination of the line so the inclination is what degree value is it having, or what angle measurement is it making with the x-axis, right? Slope is just how the line goes up or down. Okay? So there's your connection. It says your slope of the line is not directly tied, but it is saying that it's the tangent of the angle measurement itself.
So is inclination just angle?
Angle with the x-axis. Okay, so let's draw this guy out here. Let's see. Let's first draw this, because I think we can draw x. 3x plus 2. Sorry, 3x plus 2x plus 3y equals 6. Yeah. All right, guys. First of all, quick draw that little line right there, and we'll see where it's coming from. 2x plus 3y equals 6. Oh, it's been a long time ago. Step 1. Subtract 2x from one side. Okay. And from the other. Okay. Boom, boom, boom. 3y is equal to negative 2x plus 6. Boom. So make a little chart. So 1, 2. So I'm going to go 1, 2, 3 high, and I'm going to go 1, 2, 3, 4 over, just because I know how it's going to end. Okay, and let's grab this guy. So we start off with 2 right here, and then from here we're going to go down 2, 1, 2, 1, 2, 3. Oh, look at this, how nice, right there. There is my line. And the slope of this line, anybody? Negative 2/3. There's my slope right here. Okay, what we want is we want the inclination of the line. That's what we want. What we want is this right here. What we want is I want that measurement right here. I don't know how it comes in as it hits the x-axis.
What is this equation have this? The end is tangent.
Let's go with it here. So if we have this, if m is equal to tangent theta, what we want is we want theta, because that's what theta is right here, right? Okay, one more thing from trigonometry, just this one little piece. To undo tangent, what we do is we do the inverse of tangent. So here it is. I'm going to do this, Joe. I'm going to go tangent, inverse of m, tangent, inverse of tangent itself. And these two cross out. So if we take the m value, take tangent inverse, it's going to give us the inclination right away. Or maybe right away, we'll see. All right, so with your calculators, let's jam to this guy here. Oh, sure, absolutely. Yep, absolutely. One, two, three. Mhm. Mhm. Okay, and then get out your calculators here. So we're going to do a few things on our calculators first. So we are not in degree measurement, we are in radian measurement. Yeah, let's actually, because we could do it both ways here. The official answer needs to be in radian measurement, but let's do this here. Let's do degrees first, and we'll do the other one as well. So if you click this little mode button on your calculator, mode, and then go to degrees. We're going to do it in degrees first, and then we'll switch to radian because of the homework is in radians, but it's easier to see it in degrees. Okay, everything else is good like that on your calculator? Everything else is okay. So let's go quit out of here. Back to the beginning here, and we are going to do is, oh, let me jump to this little thing. We're going to figure out this based upon tangent inverse of a -2/3, because that's our slope. Okay. Okay. Let's see. We can see. Oh, there's trig functions called sine. This is sine. This is cosine. This is tangent. And you got this little tangent to the -1. That's the one we want. So we're going to go second function, tangent inverse. -2 divided by 3, and click enter when you're ready. Click enter. Oh, that's no fun. Does that look like the angle over here?
Yes.
No, this red stuff. We can have negative angles here, but that should not be a negative angle. It should be a positive angle for inclination. Say again, guys.
It looks like that line. It's like 1/3 of the 90 degree. It's like that. No.
But it's obtuse angle, so it should be larger.
Yeah, it should be larger than 90. That's right.
Which.
So here it is. One little thing the book explains all the way at the end here, but we'll do it now here. So for obtuse angles, our inclination is going to be whatever we get for this guy. And we're going to have to add either pi or 180 degrees, one of the two. We're good. So let's do this here on our calculator. Let's do this here. We're going to add, so plus sign 180 degrees, enter. Does that look like 146 degrees?
So plus pi or plus 100?
Yeah, depending which you're. Okay, so now let's do it in radian measurement, which is the way the book wants you to do it, which is the homework. So obtuse angles, you have to add this little extra pi or 180. So now real quick here, go back to your mode button. Now you're going to go to radian measurement right here. Radian measurement. Quit, clear if you want to here. So let's go tangent inverse of -2/3. Enter. And you get a decimal of -0.588. Plus, where's pi?
Plus pi. Pi is all around. It's the up x going.
Oh, yeah, you're here. Right below clear, right above the little caret key, call it. That's pi. Enter 2.55 is what we have.
That doesn't seem fair.
Yeah. So let's see.
Oh, in radians.
2.55. Now let's go back over here. Let's go back to our little thing that we did over here. 2.55, is that about right? So 1, 2, and 5 is about like somewhere over here.
Yeah, okay, I see.
That's kind of how our angle was formed. It's about like that much. That makes about sense, I think. Okay,
So much important information. I feel like everything on this page circle is important.
I saw.
Please.
Okay. Jamming. Let's go over here. And then let's change it up. Let's go with that's how much time we have. Let's do an easy one here. Let's do example 1, example 2. Find the inclination of a line of the line. Okay, we can graph the line first. Whoa, I think that's me. Oh, do not disturb. Yeah.
Is the angle always going to be on the right side of the line?
I did not do.
After trying, you add pi over the top.
Okay, so 3x minus 1, I think it's going to be like this right here, right?
So the acute angle, we don't do that side, right?
So I'm going to go here, here. Yeah, good.
We don't need to add pi for acute.
No, not for humans. Yeah, it's just because you go above 180 here. Oh, okay, cool. I think I'm good there. I think I'm good here. All right. I got M is equal to, oh, my bad. 3, is that right? I just need a slope out of there. Cool. Going over here. And for acute angles, it's just going to be this right here. Love it. Does that look like, oh, hold on, that's radian measurement. Hold on. That's what they want the homework to be in, but just for us to. Mhm. 71 degrees, does that look about right? 71 degrees, 71 point. Okay, so that's in degrees. The homework is always gonna be in radians, so let's go with tangent inverse. Hold on. Homework. Radians, that's the way the homework is gonna be. So you go second, 3, and it's gonna be 1.25, looks like. Okay. But again, we're just checking it with angle measurements. Okay, next formula here. Okay, next, a bigger formula. That was the easy one. Ready? So find the angle
Oh,
It would
no.
not be difficult to keep it. Oh, okay.
Okay.
Let's say the way that they're neat.
All right, let's do this here. Can you guys graph these two lines?
I think we should not progress this anymore.
Yeah, this is beautiful. This is nice.
So let's see, I'm going to add 4 to both sides. Is that okay? And then I'm going to subtract 2x from both sides. Oh boy, okay, a little bit of work here. I could just add y to the other side, huh? That'd be a lot easier. Just move that over. This would be 2x minus 4 is equal to y. Switch it back around. And I'm ready to go for graphing. This one.
You just subtract one line and multiply it by the
True, yeah. This one, I'm just gonna do it directly here. I'm gonna do it 2 steps here, but Abby, go for it. You're gonna do that. I'm gonna subtract the 3x, add the 12, then divide that by 4. And done. Okay, can you guys graph those?
Yeah, exactly.
All right, hopefully you guys graphed them or are about to graph them. So 2x minus 4, I need to graph them as well. So you guys ready for that? I'm gonna 2x minus 4. So I'm gonna make some graph paper here. One, two, three, four, 5. 1, 2, 3, 4, 5. Somewhere in that range, I guess. Minus 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, I think I'm ready for it. So minus 4. 2. I'm starting here. Oh. 1, 2, 3, 4. Up to 1, 2 over 1 here. I can keep on going, is that right? Up 2 over 1, up 2 over 1. That graph is off just a little bit here. I'm gonna go like this. Okay, so here's my line coming across, supposedly kind of straight. Okay, -3/4 plus 3. So then 1, 2, 3. 1, 2, 3, 1, 2, 3, 4. So I got myself a line that goes like this. We are looking for, now it's going to be the one that's less than 90 degrees. So as you look at your graph, I think it's going to be this one. I think that's the one that's less than 90 degrees. Because that should have came in. My graph is kind of off. That should have come in a little faster. Okay, formula.
Why
You guys
are
ready?
you looking for the one that's less than?
Because your tangent line is only going to work for the way the formula set up is only going to work from 0 to 90 degrees.
That's not that.
Yeah, so it's going to always be the acute angle.
So if it's between multiple, two lines, it's always going to be an acute angle.
Yeah. So here it is. Angle is going to be tangent inverse of, you guys ready for this formula here? Absolute value of M2 minus M1, 1 plus M1 times M2. Right. Cool.
Yeah, why do we have to have letters? That was better when it was just. I remember that. I was gonna do that.
Okay, so I guess we need to figure out some slopes here. Slope 1, slope 2, and eventually it's going to be, we drop the negative sign out of them anyways here. So let's figure out our two slopes. Yeah. Oh, just making sure that you answer
What
that.
are the straight lines in instead?
Oh, absolute value.
Ah, good.
Okay, so my two slopes are, it doesn't matter which one you pick. Let's see. Let's see, 2 and -3/4. Those are my two lines. So I'm going to designate line 1. It does designate line 1. So if this is line 1, this is going to be M1. No, just for the sake of doing the same computation as the book.
So if you
Switch them around.
is M1 and M2, you would still do the same.
Yes, correct. So 2 minus -3/4. So M2 minus M1, -3/4, right? -2.
Sharon, it's absolute value, so it's not negative 3/4, right?
Yeah, we can do it all the way at the end though. So this would be 8/4. This would be -3/4 plus -8/4. So on top, I got myself a -11/4. You guys okay there? That's just M2 minus M1.
And take away the negative, so it's just 11/4.
11/4. When we do the formula stuff. What's that? Now we need 1 plus M1 times M2. So let's do that one here. 1 plus M1 times M2. And we'll take the absolute value of afterwards here. So it was, what's M1 again? Anybody?
M1 is 2.
2. Thank you. Multiplied by -3/4. Perfect. What, -1 minus 6/4, is that right? So this is 4/4 minus 6/4 makes awesome -1/2. Okay, let's jam here. So now we go to absolute value, -11/4 divided by 1/4. Oh man, you know what? Because of the denominator over there,
Negative one, let's divide by 1.5.
1/2, okay, 1/2. Okay, so first things first, the negative signs fall off, right? Just because negative, eventually they're gonna fall off anyways, right? And then we have ourselves a division between two fractions. That's not always fun. So we're gonna do like this. We're gonna say 11/4 multiplied by 2/1. Good there? Keep change reciprocal or keep change? First fraction remains the same.
1, 2.
Now I'm gonna cancel these guys out, okay? I'm gonna go 4 and 2, reduce 1 and 2. So I'm gonna go with the 11/2. Absolute value of 11/2 is 11/2 or 11/2. Almost done, almost done.
10 inverse times 11/2. In radian mode also?
Let's do degree mode first, and then we'll do radian mode here, just so we can kind of see it here. So mode degrees and tangent inverse of 11 divided by 2 enter. Almost 80 degrees. That sounds about right. Almost 80 degrees. So let's do this in radian mode now. Enter. Tangent inverse of 11 divided by 2, 1.39. Absolutely here. So the angle measurement between the two angles in radian mode is 1.39. Okay, done for the day. We didn't get to one little extra thing called the distance between a point and a line, but we'll get there on Wednesday. Other than that, have a good Monday.
And you know the answer.
Don't do anything I would do.
If everyone gets it wrong, then